Hello everybody, I'm George Runkle, Runkle Consulting Incorporated. I'm a structural engineer and our specialty is container structures made from recycled shipping containers. So let's take a look today at one of recent one that we're working on, and this is a favorite of mine because of its simplicity. We'll start here. Let's go back over to the architectural drawing here. This is just a one-story building, one floor. You come in, you've got a foyer, you've got a living room, dining room right up here with a big window across here, okay? You've got a kitchen, dishwasher, refrigerator, kind of a small kitchen, small bath in here for the 2 bedrooms here, and a master bath, which it's about 8 by 8 feet. Not real big, but it works. You have a little master sitting room, which is probably about 8 by 12 feet. And here's your master bedroom. Again, it's not real big. You can put a double bed in here and still have room, but it's not huge. This is like the other way from going with the McMansions that were so popular in the early 2000s. This is more of our tiny houses. It's not tiny. It's about 960 square feet. Each container is 320 square feet, which is, if you look at days gone by, that would not be considered a unrealistically small house. And you've got 2 bedrooms and master bedrooms, a 3-bedroom house, so you could have a family with 2 children and the parents. There's not a whole lot of room for all sorts of extra stuff in this type of a house. The more of the idea is this is a place to live in, and you don't have loads of stuff. You live in here and you have a simple life where you don't have possessions that just kind of overwhelm you. And my experience is your possessions will match the space that you have. If you have a house with 10,000 square feet, you're going to have 10,000 square feet of possessions. You won't have vacant space. If you've got 1,000 square feet, that'll keep your possessions down to what you need instead of just about every kind of stuff that you can imagine. I've been in houses where they've got all kinds of junk like kayaks in the basement and stuff like that that's never used because the stuff just grows to fill in your space. All right, so here's our basic architectural drawing, and let's go on to the structure, okay? So the structure was done in different software. I did that in Autodesk Revit, which is 3D software. And here's my floor plan here again. Now what I've done is this is simplified. I didn't put in all the interior walls. The interior walls are not load bearing. It doesn't matter where they put them in. After they put these on site, they can put the interior walls any place they feel like it. It doesn't matter. This is the structure. And this is one of the things I kind of like about containers. It's like doing a commercial building in a way where I can design a structure and give you your open space and you can do whatever you want in there. It doesn't affect me. If I'm doing a wooden structure, I get a bunch of walls that are going to be load bearing, and it can kind of get kind of weird how the walls are that are load bearing, and it doesn't give you a lot of freedom as an architect to move around your interior walls as you like to if you change your mind because you've got this structure that is dependent on the walls being there. Let's talk about a couple of things about what makes this so good. This is your widest opening, 9 foot 11 inches, because it's under 10 feet. Now this is a rule of thumb. It's not a rule of design. It depends on the structure. But generally openings that are less than 10 feet, you don't have to reinforce. And my calculations confirm this with this one. One of the things is not only do you not have to reinforce the top rail on top and the lower rail, but I don't need to reinforce the edges of the corrugations that we've left in place. Let me show you, for example, what I would have had to do. I would have had to put, normally, in a higher building, like if we're getting over 2-3 stories, I'm stuck reinforcing these edges here. And what happens is I'm using this reinforcement as columns to carry my load down to the foundation. So then we start ending up with an issue. This is only got one set of foundations along the center line, two foundations. The edges can support themselves the whole length because the corrugations are left on. If I ended up with more than one story, I very well might have to add another line of foundations. But I definitely, if this was more than one story, I would have to have, at the very minimal, columns here carrying up the load from above on down to this foundation. And the same here. I would have to have columns here. I wouldn't be able to set this foundation right in the middle of these rails. This foundation would have to be offset here at the edge here of this corrugation so I could carry the load from the top. And then it gets worse as if this floor isn't carried the same all the way up to the top. Then I have to start getting into more nonsense with the structural reinforcing. And the more nonsense I get into, it means the design is harder. If the design is harder, that means the construction is harder, and that means your expense goes up. Now, one of the nice things here too, take a look at this. Because I have no columns, I didn't have to reinforce the lower rail. If I had columns here under each column, I would have to reinforce the bottom rail by putting in steel plates. And that adds to your cost. We got a weld at the bottom, weld at the top, so that's some labor plus the cost of the steel plates. The labor is not insignificant for a welder at the time to cut the steel plates to make them fit. That takes some time too, because this isn't something that's an exact measurement of steel plates as they come. They have to be cut to size, and we're starting to run up our costs. But since we did one story, I don't need them. I can take them out. All right, let's go ahead and take a look at the 3D drawing, and that might help you understand better what we're doing here. So let's go up here to 3D, and here we are. Here's our 3D drawing. This is absurdly simple, okay? We have no structure on top of the roof for roofing. It's just going to be what we call a rigid insulation, probably polyisocyanurate, which will slope from this side to the other to get the minimal slope that's needed for a flat roof. We've got a gutter that'll go on this side, and the gutter is just going to be setting in this channel that I've got here. And I'm able to span the channel most of the way across, but I had to support it at the midpoint using an angle, just 2x2 angle to hold it. It just didn't quite make it without deflecting. Now this right here is just going to be a 1x8 fascia board. It's going to be cedar so it doesn't rot. And we've done the same over here with the 1x8 fascia board, and that's just going to be held up by sections of this 8-inch C channel that we're using. Over here, this is an 8-inch C channel. Now up here, this is just going to be a canopy that's setting across on top of here. Let's go ahead and take a look at our sections here. We'll take a look at our canopy section. It's just going to have reused corrugated sides from the containers on top. I'm going to put angles here at the ends to support the ends of the corrugated sides and just screw it into the angles. It'll drain right here onto the roof and then drain to the side to our gutters. And it's going to be held on the door frame by an 8-inch channel, and then the channel supporting it welded to the 8-inch channel. And if you want to take a look at the section, it's going to look something like this. Here's our door. It's going to be welded to the door here. Going to come across here, and then we'll put another channel here. And they'll be welded together on this side to here. And then this is welded to here. And these are C8 by 11.5 pound channels. All right, so we've got through that. And let's take a look at wind bracing. We're good in the longitudinal direction because we've left quite a bit of the corrugation's on. And if you do an analysis, it can stand up to quite a bit of wind load. So we're good there. Now on the sides we're good because we've put two containers together, and when you do that, you get quite a bit of reinforcement, you get quite a bit of strength in these frames. So we're good there. And on top of that, we've got within the distance that's allowed for a braced wall line, this corrugation right here all the way across. So we're good in a number of ways. On this side, we've got corrugation all the way across here, corrugation all the way across here. We've taken the wall of the doors out here, but given we've got corrugations here and here, we've got quite a bit of reinforcement. This can withstand quite a bit of wind load. Now that's a pretty good deal. If you get hit with any kind of a windstorm, it can be pretty severe. You can go into the inner part here and you're safe. If it got a direct hit from a tornado, of course, you're probably not going to do too well. I wouldn't want to bet on how if you would live. But even if you had a tornado come by and it's throwing all the missiles at you like it does, you know, the branches, the trees and all that, you're safe inside of here because of all this corrugated metal here. And this is not going to rack. It's not going to fall over. It can get a pretty close hit from a tornado, and it's not going to peel like a banana does. If you look at a structure that's been hit by a tornado, the outer part just peels right away. It's a mess. Okay, so that's my structure here, and I hope I've carried across to you why this is so good. It's not going to win any awards. It's nothing like Frank Lloyd Wright would design, but you're not going to pay what you would pay to build a house that Frank Lloyd Wright designed. You're going to pay much cheaper. I'm of the opinion that this is kind of what you want to do for housing for families that are starting up, people of low to moderate incomes, people like me that are older, that have kids that have grown up. There's a lot of advantages to this. This is what a lot of people have considered for container houses, but so far all the designs that I've been given have gone overboard, and the containers were the container houses were too expensive and didn't get built. This is going to get built, and I don't know what the costing is going to be. I think it's going to be relatively reasonable because we're not doing any special welding. We're doing a couple of welds like here where we're putting this up and this canopy up and this thing on the side, but everything else is pretty much conventional construction. Oh, I have to take it back. We're going to weld these corner castings to steel plates that are going to go on top of the foundation. That's not a significant amount of welding though. That'll be just some quick welding in the field. So all in all, this should be very reasonably priced and shouldn't kill them with our price per square foot. So let's see how this goes. I'll keep you up as the house actually gets built. And thank you for coming to my channel. And please like the video if you like it. And please subscribe to our videos. We'll be trying to put up a couple of videos, or at least one video a week as we can. And thank you very much. And you have a good week. And thanks again.